Good morning, good afternoon, good evening, whenever it is you're watching. Thank you for joining us again on our talk this time about section 7.13 bases, naming, and formulas. Of course, all of this information comes from your CK12 packet. So, what different things are these workers? What what different things are these workers doing to make soap? All right, so we're going to talk. Our introduction will be about making soap. Who's going to help me?
Soap making has a long history until recently. Soap was made using animal fat and lye from wood ashes. The lye served as a base to break down the fat and help form the soap. Needless to say, unless the soap was washed to remove the lye, it was very harsh on the skin. Many families would make their own soap by boiling the lye and fat in a large kettle over an open fire, a long and hot task.
Great job, Miss Alexia. Thank you so much. So, soap, they're breaking down. Well, they're telling you, that these workers are creating soap in the factory, right? It looks like they're in a factory. You can see these giant kettles. You can see them bringing in and out the different ingredients that are needed to create soap. And they told you that two of the main ingredients is animal fat and lye from wood ash. Okay? So when you're talking about lye, I looked it up because I wasn't really sure about what it actually is. And it says here, um, and I probably should not be looking at this definition. I was looking at the Wikipedia, which is obviously not a good source of information. But lye, according to dictionary.com, is a highly concentrated aqueous solution of potassium hydroxide or sodium hydroxide. Any solution resulting from leaching, percolation, or the like. So it's basically that hydroxide part of soap. Okay. So you always have to remember, why are we talking about soap? Because soap itself is a base. You have heard right now that I just mentioned the lye that creates soap is a hydroxide. Okay. And hydroxide is one of those polyatomics that tells you that you're working with a base. Okay. So let's start talking about what exactly a base is. The simplest way to define a base is that first, it's an ionic compound. It's an ionic compound that produces, the second part, hydroxide ions when dissolved in water. Okay? So the first thing you need to remember about bases, it's an ionic compound. Technically, we've already covered naming and formula writing for ionic compounds. So technically, you know how to do this. So we're still going to review it. Second most part of this definition is that anytime you drop a base into water, hydroxide is always going to break apart on its own. One of the most commonly used bases is known as sodium hydroxide, and it's shown below in picture A and B. In picture A, you have sodium hydroxide, a base, is a solid that typically produces small white pellets. In picture B, the structure of sodium hydroxide is shown as an extended three-dimensional network. The purple spheres are your sodium ions. The red and white spheres are your oxygen and hydrogen atoms, respectively, which are bonded together to form this hydroxide ion. Okay, they don't really show it here, but you got to remember that all ionic compounds basically look like a box made of marbles. Okay, very organized, very structured. There's bonds everywhere, and I actually pulled up some pictures to remind you what it looks like. So you can see here from the picture that I pulled up is that your ionic structures, they all look like little boxes made up of marbles. In this case, this ionic compound has only two different elements. If I were to bring up sodium hydroxide, you would see that picture that we have in the Pear Deck where you have three different colored marbles. Okay? But all ionic compounds, look it up. All of them look like marbles connected to each other and organized in a box-like structure. Define a base. Use the information that we just talked about in the last slide and define what a base is. Okay, I will be waiting. I'm going to give you some time so that you can do this. Hey, Miss Hania. Let me change your attendance while you guys are doing that. I'll give you some thinking time. Thinking time. Miss Hania. All right. No responses about the definition of a base? Come on, guys. What about in the Google Meet chat? Oscar, Irvin, Mario, Efrain, Kevin. What is the definition of a base according to what we just talked about? Remember, there was two main points. Two main points. What was the first point? What did we say? What type of compound is a base? Do you guys remember? What was the second part? What happens if you drop a base into water? What always breaks apart? They started to write and then they deleted their response. Hello, anybody out there? I need help on defining what a base is. Oscar, Irvin, what is a base? What type of compound? What are those? Oh my God. Oh. What is the definition of a base according to our reading? It's been bothering me. I think I need to go get new contacts. Nope. Doesn't want to stay. What is a base, guys? Please. The bottom? The bottom of what? No, in terms of chemistry, what type of compounds? What is a base? What is the definition of a base?
The simplest way to define a base is an ionic compound that produces hydroxide ions when dissolved in water. One of the most commonly used bases is sodium hydroxide.
I just told you that, right? I just told you to remember that bases, number one, are ionic compounds, and number two, they produce hydroxide when you drop them in water. This is what I wanted for this slide. Please pay attention, Oscar. And everybody else, not just Oscar, because nobody was able to give me that definition. Pay attention, guys. I don't know what it is you're doing, but I need you to focus. Names and formulas. Like I said, naming and formulas is a review because technically you've already done bases. Bases are ternary ionic compounds. We did those on Friday and Saturday. Thursday and Friday of last week. We said when we name a ternary ionic compound, we don't change the name of the cation. And if my poly is an anion, we don't change the name either. But the thing about bases is that every single one of them will end with the same polyatomic. So that's like saying Oscar Mendoza, right? And then his dad. What's your dad's name, Oscar? Or what's your mom's name? Carolyn, right? So she's Carolyn Mendoza. Just like Oscar Mendoza, Carolyn Mendoza, all bases will end with the same last name. Okay? Carolina, sorry. So in the case of bases, you have the same ending. You're going to have that ending of hydroxide in the name. And there's some examples here in the slide. They tell you the first example, NaOH, CaOH, NH4OH. All of them have the same last name. Sodium hydroxide is like Oscar Mendoza. Calcium hydroxide is like Carolina or Carolina Mendoza. And then, the name of his dad, ammonium hydroxide, right? Let's say he's also Oscar Mendoza. Okay? It's like they're all part of the same family. They're all going to have the same last name. It's just the first name, the first part of your base that will change. Okay? Is everybody clear on that? Notice that because bases are ionic compounds, the number of hydroxide in the formula does not affect the name. The compound must be neutral, so the charges of the ions must be balanced as for other ionic compounds. And then they go back into the first example for sodium hydroxide. Sodium hydroxide starts off with Na+1. So if I go into Jamboard and I put in there, well, first I need to put in the fact that I have hydroxide, right? Hydroxide is always OH with a -1 charge. They're telling me for the first example, you had Na with a +1 charge. Well, you treat it just like the way you treated it last week. Verify if your charges cancel out. Are they the same number? If they cancel out, you cross them out and you bring everything else together. If they don't cancel out, they're different numbers, then you're going to have to cross them down. Make sure you protect your poly from the number that is crossing down using those parenthesis signs. Remember this? Parentheses? It's coming back. So what happens in this example? If you have a +1 and a -1, do your charges cancel out? Yes or no? If the answer is yes, then all you do is you put the elements together. If the answer is no, they don't cancel out, we do the cross-down method. So what happens here? Do these charges cancel out? Irvin, Yalexia, Mario, do they cancel out? Does this number you see here match?
They're the same.
They're the same. So what happens?
You cancel them out.
And my formula is NaOH. Sorry. NaOH. And we're done. That's the first example they talk about. The second example is talking about calcium. Calcium, they tell us, is Ca+2. So I'm going to start off by just putting the hydroxide every time because that never changes. Okay, in this case, do your charges cancel out? Step 1, do your charges cancel out? Step 1, yes or no?
No.
No. What's step 2 if they don't cancel out? What's this method? What do I call it?
You cross them.
You cross them down. But before you cross them down, I need to protect the poly. So I'm going to put parentheses. What's my formula if I cross this down? Type it in the chat or come off mute and tell me what to write. Type your answer in the chat or come off mute and tell me what to write. Very good. We end up with CaOH in parentheses and a 2 on the outside. Very good, Miss Alexia. Irvin, did you see what happened there? Mario, did you see what happened? Any questions? Kevin, any questions? Okay, I don't hear any questions, so I'm going to move on. Name the following compounds. Name the following bases. Remember, they're part of the base family, so they should all have the same name. Oscar Mendoza, Carolina Mendoza, and then Oscar Mendoza the father. How would you name this base? And we're going to need to know the name of K, and we're going to need to know the name of Ca. So we're going to go to our valence sheet. What's the name of K towards the top of the page? What's the name of K?
Potassium.
Very good. Right here. Towards the top of the page, right? Potassium. So you know the first name, right, Irvin? All of them have the same last name. Hydroxide. Put them together. What would you say? What's the name of this compound? What's the name of this compound? You know the name of K. You know the name of OH. It's hydroxide. Now put them together, Irvin, and type it out or just come off mute and tell me what the name is. Irvin, you know the name of the first part. It's this guy right here. You just told me. Potassium. What's the name of OH? Over here. You know the first part. You know the second part. What's my full name for this compound? Anybody? Anybody? Potassium hydroxide. Yes, sir. Great job. Don't forget, potassium only has one T. But great job, Oscar. Thank you. Okay, letter B. What's the name of Ca? It's going to have the same last name as the last one, right? It should end in hydroxide. Your question is always, what's the first part of my name? What's the first part of this guy's name? So we go to the valence sheet. Look it up. Calcium. Okay, Alexia. Now, you know the end of the last name. It's the same as letter A. Put them together. What do I get?
Calcium hydroxide.
Yes, sir. Very good. For letter B, you would have written or said calcium hydroxide, just like Irvin when he came off mute. Thank you, Irvin. Thank you, Irvin. Okay. Second Pear Deck question. Write the formula for the following bases. Write the formula for the following bases. You start off with calcium. The second part, hydroxide. So when you go to do the work, you should always start with OH -1. OH -1. Now, fill in the blank. What is the first part? What is the first part of each compound? Okay, CaOH. If you look up calcium, Ca plus 2, right, Irvin? Ca plus 2. Okay, if I put Ca plus 2, what did Alexia forget to put?
The 2 at the end.
Girl, then why didn't you do it? Right? She forgot to include that OH after the parentheses should have a 2. Be careful, Miss Alexia. Okay, what about the second one? Strontium. According to your valence sheet, what's the symbol and the charge for strontium? What is the symbol and the charge for strontium? And what kind of formula would I end?
Sr positive 2.
Okay, so si yo pongo eso ahí, if I put that in here, what's my formula? Strontium. Sr. Very good. This guy needs to cross down. We need to protect the poly with parentheses, and we end up with SrOH and a 2 on the outside. Okay? Sorry. I didn't sleep well last night. Tossing and turning most of the night. All right, listen up here because she does talk about some properties of bases that we did not discuss.
So now we're going to move on to another type of compound that we can name and write formulas for, and that's called a base. Now, bases are used for cleaning supplies. Bases are going to be used for soaps and bleaches and things like that. So we're talking about now anything on the other end of this spectrum, this pH spectrum. We're going to be talking about bases. So the key with bases is, one, they're used to break down certain items. They're used in cooking, okay? Like you can see like baking soda, that's slightly basic, okay? So bases, they increase in power, okay? So the stronger bases are going to have a higher number. And so bases, we're going to be identifying with 2 elements put together, and that's called OH, which is called a hydroxide. Okay, so let's jot down some of these notes, but the key that we're going to be using is that anytime you see an OH in this compound, in this OH combination, that is a clue that we have a base, okay? So we're looking now at your notes. We're going to be on page 5. And so let's just jot down some of those things that we just mentioned. And the fact that anytime you hear this word base, we're talking about a compound with an OH, a hydroxide. Now, they feel very slippery. That's why they're like soaps, cleaning supplies. But they also have a very bitter taste. Not that you should be tasting bases, because keep in mind, folks, look at this. They are cleaning products. You should not be drinking bleach or anything like that. Eggs, baking soda, they're slightly basic, so your stomach can handle it. But the cleaning products are way too strong. You can get too sick from it. So I'm not encouraging you to go taste them, okay? But the key is that bases have one thing in common with acids, and it's the fact that they can conduct electricity. That's the only similar characteristic they have is this 5th one, okay? And the only way you're going to know you have a base is because of this hydroxide. So let's do a couple of examples with this, showing you how we're going to be recognizing bases, either naming them or writing their formula. So now we're going to move on to the next page. And so if you notice, all of these elements have an OH. So anytime you see an OH, which has a -1 charge, you're thinking that's a hydroxide. That's a clue that we have a base. So our first element, the way that we're going to name these is you write the name of that first element, which is sodium. And then you should always get in the habit, guys, when you write these, because they're still technically ionic, go to your periodic table and check. Is sodium in this Roman numeral area? Okay, those boxes. Sodium is in group 1, so we're safe, so we're good to go. So that means we can move on to the OH part. Now notice it's in parentheses. That was a visual clue that I had said, which is it's a polyatomic ion. So if you look at the very bottom here, you're going to see that hydroxide is OH minus 1. Or the other clue is that I said all bases have a hydroxide. So OH's name, we're going to write down, is hydroxide. Okay, so then look at our next example, MgOH2. Mg is magnesium, so we're going to jot down magnesium. OH2, now before you move on to the OH2 part, which I almost did, you want to double check and look, is magnesium in the Roman numeral area? Is it a transition metal?
Okay, so right now she's asking about Roman numbers. Remember, Roman numbers are only used for metals that have multiple charges. So it's going to require an extra step. It's going to require for you to uncross the charges. The subscripts need to go back to their original. And if you have a metal that has more than one charge, like iron can be a +2 or a +3. When you uncross, it'll tell you which one you're doing. Okay?
Do I need any extra items to name this? And you don't, because it's not in the middle. So that means that I'm going to be naming this compound and moving on. And so that my OH is just a hydroxide.
Okay. So I think that's enough practice on about naming. I'm going to forward it to where she starts talking about these two examples, aluminum hydroxide and copper hydroxide, because there's something that you need to remember about those. Okay. So I think it's over here.
So I'm going to write that down. So aluminum has a +3 charge, so I'm going to write that down. Hydroxide, that's that OH -1, and I'm going to put OH in parentheses, the -1 outside. And then step 3 said to do the crisscross rule, so dropping down these numbers diagonally to make sure that our compound is neutral, has no charge. So we're going to end up with Al1OH3. I ran out of room. Now, you're probably thinking, but you didn't say we didn't need the 1, and you don't. You can actually erase it, and you can just leave it as AlOH3. It will mean the same thing, whether you have the 1 or not. Okay, so last example. Copper, Roman numeral, hydroxide. Copper is Cu. Okay, it's going to have this Roman numeral is telling you copper's charge, so +2. Hydroxide is OH -1. So your final answer after you crisscross to make this compound neutral is going to be Cu1OH2. So this is how we name bases. Notice the difference between acids and bases, the fact that there's a hydroxide in bases. Acids only have a hydrogen.
So anytime you see a Roman number, guys, anytime you see a Roman number in the name, that's the charge of the metal. More than likely, that metal has more than one charge. So they're telling you the charge. If it said copper 2, that's the charge of the copper. Okay? In summary, bases are ionic compounds that produce hydroxide ions when dissolved in water. The second point is that the cation is always named first, followed by the last name, hydroxide, which all bases have. Your review questions. What is a base? What is the charge on the hydroxide? Number 3 and 4 are all about naming and writing formulas for bases, okay?